Section 6.3. Factoring trinomials whose leading coefficient is not 1. In this section, we continue using trial and error method to factor trinomials, but this time, leading coefficient, when it's not 1, will just add a little more complexity to the process. Example 1. Factor 5x squared minus 14x plus 8. Notice that the leading coefficient of 5 will impact the factoring process. Just like before, I open two pairs of parentheses because I know that trinomials of this form are resulting from multiplying two binomials. First terms of each binomial have to be resulting in 5x squared. The only way to divide 5x squared into two factors is 5x times x. Because 5 is a prime number, this task is not difficult. Now we look at the constant term, positive 8. There are two ways to factor 8. 1 times 8 and 2 times 4. We need to choose the pair of factors that, if placed in the second position of each parentheses, would give me a product of positive 8 and the sum of negative 14x. Please make sure to pay attention to the fact that 5 as a leading coefficient right here will impact whatever number you place in the last position. I see that the pair 2 and 4 are suitable for this task. I place 2 right here so that it multiplies with a 5 to give me 10x, and I place 4 so that it multiplies with an x to give me 4x. 10x and 4x is 14x, but notice I want both of them to be negatives to give me a negative 14x as the middle term. Here is the factored form of the original trinomial. 5x minus 4 multiplied with x minus 2. Example 2. Factor 6x squared plus 19x minus 7. Let's take a look at what two factors could give me 6x squared. There are two possibilities. I could choose to divide 6x squared into two factors as 6x times x or as 2x times 3x. Remember that this method is called trial and error because sometimes you try something that may not work. It is no normal process. Don't give up too soon. To illustrate this trial and error process, let's say I choose to write in my first position of each binomial 6x and x. Now I will look at negative 7. 7 being prime gives me only one choice. 1 times 7 are the two factors that could give me 7. However, because 6 multiplies into whatever I'm going to place right here, I may actually have two options here. 1 and 7 or 7 and 1. Changing order in which I place these factors in these parentheses will make an impact on the result. Let's see if either one of these possible choices will give me the desired middle term of positive 19x. Six x times 7 is 42x, and 1 times x is 1x. There is no way for me to find a 19x out of this combination. 6x times 1 is 6x, 7 times x is 7x. Again, there is no way for me to get 19x from this combination as well. So this doesn't work at all. What do I do now? I go back and I say This pair didn't work. Let's try the next pair and start all over again. I write again two pairs of parentheses and place 2x and 3x in the first positions. Now we're back to constant of -7. There are two ways to write factors of 7 in the second positions of the parentheses, 1 and 7 or 7 and 1. Hopefully one of these combinations works. And I actually can see clearly that having 7 multiplied with 3x would give me 21. Having 2x multiplied with 1 will give me 2x. 21 and 2 are 19 units apart. I think I found the pair that will work. Now the matter is to choose which signs belong there. Because I want a positive difference of 19x, I want more positives than negatives. Therefore, I'm going to make 7 positive and 1 negative. Please check your work. 2x times 3x is 6x squared. 7 positive times 1 negative is -7. And the middle term will come from 21x positive and -2x negative. Combined together, they would give you 19x. Thus, 2x plus 7 times 3x minus 1 is the resulting expression. Example 3. Factor 3x squared minus 13xy plus 4y squared. Let's open two pairs of parentheses. Two factors that will multiply into 3x squared are 3x times x. When we look at the last term, there are two ways to write 4y squared as a product of two factors. 4y times y or 2y times 2y. Now you have to consider what your middle term looks like. Because I want -13xy to result from this combination right here, I notice that placing 4x in the last position, 4y in the last position, and placing y in this first position may produce the middle term I want, as long as both products are negatives. Let's check our work. 3x times x is 3x squared. Now let's take a look at our product of last two elements of each binomial. -y times -4y does give me positive 4y squared. And two products, -yx and -12xy together combine to -13xy. A little note, by commutative property of multiplication, whether I have y first, x next, or x first, y next, makes no difference. The products will be equivalent to each other. Therefore, my final result is 3x minus y multiplied by x minus 4y.